Hello, I'm gonna tell you how to solve logarithmic equations. My hint, if you don't have right now a card with the properties of logarithms and exponents, it's better that you have one right now, or check a website or have it into your note in your notes or anywhere, okay? Because we're going to I'm going to do a practice. I'm just going to show how to solve a logarithmic equation, and for that you need the properties of logarithms. Okay, let's start. So we have here the logarithmic equation. So what is the main key, or one of the keys that I use to solve logarithmic equations? First, I try to have just one logarithm. It should be to both sides of the expression, or it should be to one side of the expression, but I'm trying to have just one logarithm. Then I apply properties to have exponents and solve the equation. Let's see. We have here logarithm to the base 1/3 of x squared plus x minus logarithm to the 1/3 to the base 1/3 of x squared minus x equals -1. So we can apply properties of logarithms to have just one logarithmic expression. Look at this, subtraction of two logarithms. So it means that if we apply the property, we have a division. So logarithm to the base 1/3 of a division, x squared minus x and x squared minus x. This is equals to -1. Okay, something you should take into account when you start solving a logarithmic equations is that you should know the domain of the logarithmic. So how do you determine the domain? Determine the domain. Okay, how do you know what happened to the domain? Look at, we're going to check here that x squared plus x, but remember that there's no logarithm of any number that is less than or equals to 0. So it means that x squared plus x should be greater than or equals to 0. Okay, so obviously x should be greater than 0. Okay, we can say that x is greater than 0. So let me write here, x should be greater than or equals to 0. There are many techniques to actually prove that x should be greater than 0, but it's not part of this course of this part. So we're just going to use like more our how do we know about logarithmic functions? Okay, what do we know? Uh, and for the other expression, we have x squared minus x greater than 0. Greater than 0. Okay, so it means that essentially x should be greater than 0. Okay, remember, there are techniques to find this, but we're just going to use an easy technique, that is knowing that couldn't be greater than 0, should be greater than 0, and the best option is to set the numbers greater than 0. In fact, for this second could be a number greater than 0, the limits. Okay, we're not going to get deep into this part. Okay, now we have here the expression. We're going to use the definition of a logarithm. What is the definition of a logarithm? That the base raised to the logarithm should be the argument of the logarithm, or the power. So we're going to set that this is the base, 1/3 of -1 equals to the argument of the logarithmic function. Okay, now we're going to solve the expression. So to solve the expression, first let me apply properties of exponents. -1 as an exponent just means that we have to change denominator with numerator. It means that this is 3. Now we can multiply to each side by x squared minus x. And this is what we have. Apply distributive property. And let's solve. Subtract to each side by x squared. So we have 3x squared minus x squared, 2x squared, and positive x, negative 3x minus x will be 4x. To solve this equation, we have to factor the expression. So GCF is 2x and if we factor the expression, should be just x minus 2, and apply the zero factor property. Okay, if I apply the zero factor property, we have that the solutions are x equals 0 and x equals 0 and x minus 2 equals 0, so x equals 2. You have the solution. However, remember, we told that x should be greater than 0. Oh, here there's a problem. It's greater than. It's greater than, so sorry, it's greater than, so x equals 0 is not a solution, so we say that the solution is extraneous. Okay, the solution x equals 0 is extraneous so we discard it. Solution, so the solution, the final solution, the actual solution is that x equals 2. We can use another representation like sets to say solution is 2. Okay? Just if you want, you can check the solution. If you check the solution, you can see that is -1. So how to check the solution? So 2. 4 plus 2, 6. And 4 minus 2, 2. And if you apply the logarithm, you should have that is -1. Okay, and this is how you solve logarithmic equations. I hope that you enjoy the video. Remember, you can watch my YouTube channel, Ugufin. Send me comments if you want any other video about any other topic, or to my Facebook page, Learn Think. Okay? See you. Goodbye.